Hey guys, so in the last video we did Unit 3 Section 4, which was proving that triangles are congruent. So now we're going to do proofs where we already know that the triangles, or well, part of it is we know that the triangles are congruent, but what can we prove beyond the triangles being congruent? Because once we know that two triangles are congruent, we actually know more information about the two triangles. So remember the shortcuts are, well, let me change my color here. We have side, side, side. We have side, angle, side, angle, side, angle, 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 side. And the last one is that special one for right triangles, which is hypotenuse leg. So if we look at this first diagram, we see that LK is congruent with UT, MK is congruent with VT, and then angle K is congruent with T. So we actually have enough to prove that the triangles are congruent by our shortcut of side, angle, side. Now that we know that they're congruent, what else can we conclude? Well, if they're the exact same triangle, we know that this side here, ML, has to be congruent with this side of VU, since those are corresponding sides. We know that angle L has got to be congruent with angle U. Let me do two arcs there. Lastly, we know M is corresponding with V, so that's also got to be congruent. So we get three other pieces of information even after we're done with those. So we know that angle L is congruent to angle U. Angle M is congruent to angle V. And then the side of ML is congruent to VU. All right. So this is what is called CPCTC. It's a fun acronym. Corresponding parts of congruent triangles are congruent. So after we prove two triangles congruent, then all of the remaining corresponding parts have to be congruent. Otherwise, they wouldn't be congruent triangles if it's only three parts that are congruent. So let's go ahead and try this, and I'm going to show you how we use this. So this time we are given AB is congruent with CB, AD is congruent with DC, and then we want to prove that angle A is congruent to angle C. All right, so that's our last statement, so I'm just going to write that here. So how are we going to possibly prove that? We're not actually proving the triangles are congruent for the last step, but if you think about it, we probably could prove these triangles are congruent. Just by looking at them, they do look the same. So we are given the information that AB is congruent with CB. So let's go ahead and fill that in. And then we also know that AD is congruent with DC. So we have two sides already, just based off of the given information. So let's go ahead and see if we can prove that these triangles are congruent. So looking at the angles, we really don't know anything. We don't know about bisection or if there's like an angle pair relationship, but we do know something about this third side. We know that it's shared by both triangles, so we can say that it's congruent to itself. So BD is congruent to BD. And remember, it's by that lovely property, the reflexive property. Okay, so now that we have three sides congruent for both triangles, that's actually a shortcut to prove the triangles are congruent. So we can say that triangle, I'm going to say ABD is congruent with triangle, I better go CBD. And that is because of the side, side, side shortcut. So the last step, once you see it, I mean, it's pretty obvious because that's what we were using up here. But now that we know the triangles are congruent, we can use this acronym that tells us after we know they're congruent, then everything else about them has to be congruent, like corresponding parts. So now that we know they're the same triangle, we know that A and C are the same angle. So this is where we can write CPCTC. So these proofs really aren't much different than proving triangles congruent. It's just always one more step to do. All right, so let's do this one here. Given that DAB is congruent to ADC, so I'm going to fill that in. So DAB is this angle here, is congruent with ADC, which is this angle here. And then AB is congruent to DC. AB is congruent to DC. All right, so that given information is already put there. Our last step is AC. We want to prove that it's congruent with DB. All right, and as you probably guessed, the last given reason for this is going to be because of CPCTC. So typically I wouldn't have you fill that in before we actually do it, but understand that's where we want to go. And to do that, we need to prove the two triangles are congruent. So right now we have a side and an angle, but notice this is a lovely diagram. They share this side, so we can say AD is congruent to itself, AD. That's that reflexive property. I promise you, not every single proof we do will have that. Okay, so the reflexive property allows us to say those are congruent. Now that we have a side and an angle and then another side with the angle in between, we can prove that triangle BAD is congruent with triangle CDA. No, yes. I was going to write CDB, but that doesn't make sense. CDA. And that is because of side, angle, side. And then after we know that they're congruent to each other, we could use this CPCTC, because you can only use that after proving two triangles are congruent.